Alright, so let's review our properties that we had.
Yes.
Property number uno. Opposite sides are, you can actually, I'm gonna put parallel first, but it doesn't matter which one you put first. Because the first one and two are opposite sides, so you have parallel, and then one of them has to be congruent. The opposite sides are parallel, opposite sides are congruent. Third property,
Congruent.
opposite angles are congruent. Next one, the diagonals do what to each other? Bisect each other. And then the last one, number 5, consecutive angles are supplementary. Okay, so what we're gonna do now is, we're going to show some of those properties. See where it says, there are blank ways to prove a quad is a parallelogram? We're gonna put 3. So this is gonna be a little bit of a review. Okay, so before we go through each one, I wanna do this first. Okay, the ones that we can show are these, opposite sides parallel, opposite sides congruent, and diagonals bisect each other. So if we're gonna show that the opposite sides are parallel, what are we gonna use? We know this answer.
Slope.
This is going to be slope, and we're gonna make them be the same, right? So they have the same slope. If we wanna show that opposite sides are congruent, we're gonna use Pythag. Now sometimes you'll just be able to count if it's horizontal or vertical. We'll use the Pythagorean theorem. That last one, we haven't done this very often, they haven't done it in a while. If two things bisect each other, they're gonna have the same what?
Slope. Midpoint.
Midpoint. Okay? You were close. It was a math term at least. Alright, so let's look at the first example. Method 1, prove opposite sides are parallel. So we're gonna look at that shape. We have a parallelogram like so. Now, to do this, how many slopes are we gonna write down?
4.
4, and we're gonna group the opposite sides together. So in other words, AB and BC, if we wanna show their parallel, we're gonna show their 2 slopes, right? And then we wanna show AD is parallel to BC, we're gonna show their 2 slopes. So let's look at AB and CD. Do we remember what the slope of a horizontal line is? It's actually the other one.
0.
It's 0. Okay, so you just, and if you get that wrong, as long as you say they have the same slope, I'm probably gonna, like, that's not the most important thing. Because
What's the
obviously
difference?
horizontal lines would be parallel. But the slope of AB is gonna be 0, DC is 0, so they're parallel because they have the what?
Same slope.
Same slope. Okay, is everybody good?
I just wanna know the difference between 0 and undefined.
Okay, it's because you can't divide by 0, right?
Right.
So it depends on where the 0 is. So remember, slope is rise over run, correct? So when we think of rise over run, when you're doing a horizontal line, there is no rises. It's not going up or down.
It just has a run because it's so big.
So basically, and it doesn't matter what the run is, but it's gonna be a number, let's say it's 5. So 0 over 5 is mathematically possible, that is 0. So a horizontal line has a slope of 0. Now if you flip it though and go vertical, now the 0 comes on bottom because you do not have a run. You cannot divide by 0, so therefore it's undefined. Or sometimes they'll say no slope. Alright, so on AD and BC, now we can actually find the up and over. So I'm gonna go up, I'm gonna go over. What is that, 1, 2, 3, and 1. So you guys agree the slope of AD is 3 over 1.
3 over 2.
Good, if you can count better, that will help. Or the key is, some of these, I don't know if you guys did this, or if I miscount, just miscount on both of them and make it the same. So the slope of AD is 3/2. BC is also 3/2 in it. So they have the same slope. So we have shown that this is a parallelogram because opposite sides are parallel. Okay, is everybody good on that one? Alright, let's look at the method number 2. Now we're gonna try to show opposite sides are congruent. So now we're gonna use Pythagorean theorem, or we're gonna count. So we want to show that AD is congruent to BC, right? And we want to show that AB is congruent to DC. So AD, do you guys agree we can just count? Let's see if I count right this time. Everybody get 5 for AD.
Yeah.
So AD is 5. BC is 5. So they're congruent. On AB, we gotta do Pythagorean theorem. Once again, I gotta count right this time again, don't I? So let's see, I got 1, 2, and you guys agree it's 6? Everybody make sure that when you make your right triangle for AB, it's 2 and 6. So the length of AB is square root of 40. I would do 2 squared plus 6 squared, right? 4 plus 36.
So would it, since it's a decimal, that'd be square root of 40?
Yeah, so on this one, since you wanted to show they're the same, if you put the decimal or didn't, it wouldn't matter as long as you show the other ones the same. That's why it doesn't matter in this case. And then we would do the same thing for CD. Lucky for us, we get the same things for our right triangle, don't we? So therefore, you know you're gonna get the same answer. So they're equal. We have shown that opposite sides are congruent. Okay, are we ready for the last one? Now this is the one that I don't think is hard, but it gets confusing because you're working with diagonals. And for some reason, when people look at the shape, seeing the diagonals is hard. So what we need to do first is make sure we understand what it means to be a diagonal. So first off, AC is one diagonal. You guys with me on that first? The other diagonal is
BD or DB?
BD. Okay? So what we are going to do is find the midpoint of AC and find the midpoint of BD, see if it's the same. If it is the same, then they bisect each other. So what I'm gonna have you do is look at point A and see what point it is. I've got that it's -1, 5. You guys agree?
Yes.
Point C is 6, -4. Okay, so first, do we agree that's the 2 points? So remember, midpoint is average, so I'm going to add the x's and divide by 2, add the y's, divide by 2. So -1 plus 6 divided by 2, and 5 plus -4 divided by 2. You can write as a decimal or fraction, doesn't matter. We just gotta see if it's the same on the other one. So -1 plus 6 is 5. 5 divided by 2 is 2.5. I don't know why I put a negative, sorry. Okay, 5 plus -4 is 1, 1 divided by 2 is 0.5. So if they bisect each other, when we do that over here, we should get the same answer. Everybody good so far? Okay, so now point B is, what is that, 3, 3?
Yes.
And point D is 2, -2. So we are going to add 3 plus 2 and divide by 2. We're going to add 3 plus -2 and divide by 2. And once again, I get the same exact answer. Okay, has anybody got a question so far? Okay, now this last thing, everybody ready for the last thing? Am I going too fast?
You said that there's 3 ways, why
Right.
is there a method 4?
Because we have a special secret way. So the 3 ways that I said is basically showing one of the properties. Does that make sense? So we showed opposite sides are parallel, opposite sides congruent, and then we said, diagonals bisect each other, do the midpoint. Okay, well, one property we didn't talk about, if you're talking about a parallelogram, is normally we gotta know both sides are congruent. Let me say that again. We need to know these 2 are congruent and these 2 are congruent. Okay, everybody with me? Or we gotta know these 2 are parallel and those 2 are parallel. Does that make sense? Well, the special method is I can combine those. And if I can show that just one pair is not only congruent, but it's also parallel, that works. So it's like combining the first 2 methods. You with me? So if that happens, in this case, this would be the easiest one. Because if I was gonna show they're congruent, I could show AD is congruent to BC just by counting, couldn't I? I could count AD and it is 1, 2, 3, 4, 5. And I could go BC and still get 5, right? And then if I can show that these are not only congruent, but they are also parallel. And we just talked about this, to see if you remember. If they're horizontal, what did we say the slope was?
0. Wait, no,
Undefined. So both of them have an undefined slope. So they have the same slope. And they're congruent. So they're both parallel and congruent. It is a parallelogram. Alright, so if you get that down, then we're gonna turn the page. You guys try 1, 2, and 3 on your own, then we'll go over that together to see if we understand this.